unmute myself, and I probably have to share something, otherwise the recording will be terribly boring.
It's the blue, third blue from the left.
The third blue from the there, right? That's the one. Share your desktop. Yes, that's the whole point.
Okay.
Perfect. All right. Only like half an hour late, but hey, better late than never. So this is the entirety of the API surface, right? But that's not everything here is new, right? So the new ones are probably this guy here, and then some.
There's find options, simple matcher, find transforms, find transform, find predict. All the things with find in the beginning, basically. And in addition to that, DOS matcher and simple matcher. And then some new APIs on directory and directory info.
Right.
And you can see them there. Is that like...
Yeah. Or you could grab file system info from another machine and diff it.
Now we have added into
that would be actually really helpful.
Options.
You remember where it is?
Actually, I do know where it is, yes. What's your alias?
Dan mode.
That's the
it's
one.
a new machine, though. It's possible I don't have a whole lot in the cache.
Oh, you haven't restored yet?
I don't know. Probably I have.
You can just compare it to desktop.
Probably at some point restored. Look at this beauty here. System.io.filesystem.
Yeah. Okay, perfect.
I was about to say, like, does it fucking... Oh, I probably want the... What's ref, right? So I probably want the .standard one, so it's all actually...
We did add something to
that, and then let's do the...
very clever.
Here we go. If only I could figure out how to close this. Yeah, here we go. Alright, so I guess we should probably, for the sake of it, check that because it doesn't matter. Here we go. Now things make sense again.
it's a little obvious.
So do you have like sample code we should look at, or should we just go with the APIs first? What do you think is easier?
You can just on the there's sample code in the issue, so you can look at that. It's just like the two samples that are there.
Do you remember the issue number? It's in the meeting.
25873.
GitHub.com.
So internally this is the
25873.
25783.
Internally on the Windows side, this is the surface area that we actually, or pretty close to the surface area that we actually have at the moment.
Yes.
We changed things back in the late fall to do this, based on investigations that were coming out of both my end and the project system, build system stuff in Visual Studio. I'd made some changes on the desktop side to address some of the over allocations. This was the more fundamental rewrite that I did.
Yeah, so the point of these APIs is basically do the file system traversal without allocating like a gigabyte of memory in the meantime, right?
So that was our biggest fundamental performance problem right now is that like we allocate way too much, particularly when you start to filter out things that you don't care about. So, which in build scenarios is pretty frequently, right? Like you want to look for just C# files. Well, right now it's really hard to do that. Or worse, you want to look for a set of inputs, right? You want to look for all like C++ files, right? That are source files. To be able to do that on the front end is not possible at all, right? So you end up allocating a ton of strings, like when you may not want anything from that scenario. I think that's one of the examples I gave was get a full path with an extension, with a set of extensions, right? And that's a fairly simple example, but like this is fully extensible to the point where you can actually go in and like there's a state object that you pass through. So you could like make really rich decisions as you're going along to say like, well, here's a subfolder that's in the set of folders that we know is part of our exclusion list. We're not going to go into that folder at all, right? We'll skip past that.
So that is basically the code people would write today, right? They would just basically traverse everything with a given extension, and then they would just use link to do the filtering, right?
Yeah, and there are ways to write this that like avoid some of the overhead of link. this is more for example purposes than like saying like that's the best way you can write it now.
And this API, as you mentioned before, is not aimed at someone who's just writing a relatively straightforward app or is enumerating over quite a small tree.
This is meant
barrier to entry for this, but it's pay for play.
Yes, it is performance oriented, and as such, like there is some. It allows you to get at the lower level data using span. So it's leveraging span, and in order to keep the allocations from happening, we have to pass stuff by ref. So there's a little bit of contortions we have to do that make the API not as pretty as it would be if we didn't care so much about the allocations that are happening.
Still, some of the APIs return strings.
Yes.
Which cause an allocation. Do you have alternative APIs where I can pass in?
Well, we have the directory info stuff now, but now there's the opportunity to. This is the thing that can be done. My hope with this is that like, as people can like, we have more work that we can do ourselves, providing the higher level, easy abstractions on things, but. Like the hope is that like as people are building solutions around this as well, that through the community we'll see where the common patterns are coming up instead of trying to second guess them. Like for example, like you might think right now that like getting, I just want the file name, right? I don't want the full path, don't get the whole string. I just want all the file names in this directory. That seems like it would be a pretty common scenario, but that's still guessing on our part, right? But you can do that now. You can say like, well, look, I don't need to combine the path together. I want the two pieces separate because I may do additional things or I may not even care, right? So you can avoid that allocation.
You have APIs that don't return strings, but rather
you can. So these all have a transform on them, so you get to decide whatever format the data comes out in. So you can say you can pass it out as a string, and you can decide what that string is. You can pass it out as a higher level structure or class. And we'll see what the data looks like that you get to transform from that point. So it's as low as we can get.
Is it fair to say, like, I mean, one of the problems that we have is that if you look at this code here, right? So let's say we would have just filtered to literally like the C++ files, right? Let's say just C files, like .c files, right? We could just pass star.c here, which means we would pass that filter down all the way to the Win32 API. So what they return to us already is filtered down to everything that just ends with like C. But as soon as you want to do some sort of custom processing, like is in a set of, that's when basically you go through the overhead of our machinery because we have to allocate you basically a very rich object so that you can just write, I don't only want to do the things that are actually suffixed with something.
Or I don't want anything with this particular attribute. Right?
So your APIs are basically giving you like some sort of like lower level building blocks, what you call like transforms and like predicates essentially, where you do the processing effectively above Win32, but still well below the overhead of the rich things that we give you back in strings and all of that. And the idea is that, that code is probably pretty ugly, but the idea would be that we would expose more higher level building blocks that allow us to like, front load some of the work to the customer to lower levels, and then that they don't have to write the code themselves.
Yeah, based on demand, right? So we have some building blocks that you would still be using the API like here, which I'm using a few of them there, but like if there's a set of building blocks together, like we're doing like the simple match, and people really want that, and I assume that they do. That's one of the ones that's kind of high on my bucket list, is that like I just want star to be star, and I want question mark to be question mark. I don't want to have to worry about whether or not like star dot means something on this deployment versus that one, which like foo dot means something different on Windows than it does on Unix. So
still, I don't understand one thing. You're saying that there is some API that lets me avoid the string allocations. This is not this example, because this example fundamentally creates strings, correct? Because it's a find data of string array.
This one allows you to prevent creating, like if you wanted to get multiple extensions right now, you have to get strings for every single file.
Yes.
So this one is still creating strings for every result, but it's only creating them for the results.
Okay.
And if I didn't care about like getting a full path, then I could stop at that point where I'm combining the directory that I'm looking in and the file name, right? So that even from that point, like you can pass back just the file name and you have the data, and you can.
And so
not have to create
example that shows that 100% non-allocating APIs.
Well, it's never not completely 100% non-allocating.
You're always returning a string, right? I mean,
you don't have to create an output string, but there's the buffer that's coming back from Windows. What you decide, so we're giving a span into the name that comes back from the buffer from Windows. But we still have to allocate that buffer.
So why is the buffer not allocated in the colors code?
In the which code?
In colors.
I
allocate the buffer and I pass it to Win32 APIs to fill in the data.
Well, we're doing that now, which is a difference from what we used to do. We used to allow Windows to do it, and that was another big performance hit. So, like, we don't use, and this is very Windows specific in this case, but like Windows, when you're enumerating, like as you recurse through the directories, you would create another buffer every directory you go into on the inside Windows. Now we don't call the Win32 API the find first file. We call the get file information by handle, which allows us to reuse the same buffer all the way down, and that like cuts a significant portion of the allocations off.
But then, so like if I could pass my buffer, then I could, for example, pull it.
Yeah, this one is pulled. It's using array pull, and like we could provide that as well. There's no reason why we couldn't add that in the future, but like. Or
I could allocate it, on the stack, the buffer. Correct? Is it synchronous? No, because it's async. Is it async? No, it's synchronous. The Windows API, correct?
It's synchronous, but like the only problem with that is like the buffer needs to be pretty substantial, right? Like 4K or so.
Okay, fine.
Like more so when you're actually doing
so do
remote
you have
stuff.
API that like lets me pass full buffers?
No, not yet. No. But it's what it's doing internally is using array pool. So like, there's no reason why I couldn't add that in the future if we find that was.
So I'll tell you the main reason. So like if you, for example, use pipelines, you kind of like pipelines give you buffers. You don't get to allocate. And if if you allocate buffers from like even our array pool, then you have to copy into pipelines buffer.
So basically there is a class find enumerable that you're constructing, and we can add another overload to that in the future that allows you to construct it with a buffer. So it's a pretty simple thing to do, and it is internally using a buffer anyway from the array pool, so it's all architected that way. So
why would we add it in the future and not now?
Because I'd want to like spend some time analyzing. We may do it still now, but I don't want to waste our time right now. I think there's more. Well, I don't want to get distracted by it. It's not a waste.
And so your sample code is still like somewhere because it's hard to see like types and what's actually being passed in. So like this is the key type that you basically have, right? So the idea is that if I want to enumerate like the file system, I would construct this guy.
Yep.
And then basically what I pass to the constructor is the root of the directory at which I want to start. And then I pass in a predicate, a transform, a predicate, and then
a recurse predicate.
Which basically controls whether you keep walking, right?
Yep.
And then state is whatever I want it to be, and then some find options.
Find options, which there's an option in there to use a larger buffer. That's people have been asking for that for doing SMB work and stuff like that. And also, there's about the big bucket list item is that there's an option to skip on access denied. So that's one I want to have right off in the front.
Sorry to be a pedant. The inaccessible, I think, is that typo? Sorry.
Inaccessible, what do you say?
It probably is. But
I mean, that's fine. So I have a slightly more interesting question. On the example, in the top one, you were looking for star.cs or something. That was going to the OS, right? And the OS was therefore doing the filtering, albeit using its strange rules. In your example, it seemed like that was only happening in the filter predicate. So the OS is calling us every single one, and
it sends them in groups. So that's efficient. It actually isn't. Certainly not on the Windows side, which I know some fairly painful detail, but fundamentally that buffer was always getting created, right, and always filled with the full set of data. It's just what they decided to pass back is based on that filter, if there happens to be one. And when you're going recursive, which is the fundamental one that I'm trying to solve here, is that there is no way to filter out directories. So the existing implementation in desktop is that we actually always enumerate twice. So we go to Windows, we ask it for star.cs, it gives back the file items, and we go and ask it for everything. So we can find all the directories whenever we do a recursive thing. And what happens under the covers is that you have these intermediate buffers being created at the find first file level, which is then doing transforms to take the native data back and forth out of the second internal buffer. What happens now is that none of that translation is happening. So the raw data doesn't have to be filtered out in this intermediate buffer that's coming up the stack.
Could be a hypothetical file system that would be able to instantly tell you whether there was any star.txt in a
Sure.
subtree.
And
NTFS doesn't do that, so you haven't bothered to worry about that.
No, and there's some level of like being able to still provide higher level abstractions for common scenarios that we come up with. Say some particular set of support comes in, or we find that like there's one really common case that like is actually shows up in a performance scenario that like the upper level abstractions that we're providing, where we're not providing access to the file enumerable, where we're wrapping access to file enumerable, we can have our own custom ones for those particular scenarios.
The existing simple cases, are you implementing them all in terms of these new APIs?
Everything uses the APIs currently. I mean, for Windows anyway. I haven't done the Unix side, but I will as soon as.
So what is the find all these delegates? Are they delegates?
They're delegates. So the thing to look at really is look at the find data, right? So this is really the fundamental part of where this thing allows you to go fairly low level. So what it's doing here is that like when you have your read-only span car, right? That's allowing you direct access to the buffer, right? That's being passed back. The other things are sort of trivial in size, and they're all properties because like the abstractions we have to do across Unix. So like it just so happens that like our current stuff is defined around this set of data, right? And this set of data is returned as a single block in Windows. That all comes back as the initial block for an NTFS
file. Why file name is span, but the other strings are not?
The other strings are passed in strings, so they were already allocated. Those are just well, with the example. Sorry, the directory we have to allocate something to do that. So that was a conscious trade-off. Yeah, because as we're going in and we're opening handles, we need to provide some sort of thing, and that was kind of a trade-off thing, rather than add real super complex logic around that. Said, all right, well, the thing we still allocate is a string for every directory we look at, but that's far less than what we used to, and quite often that needs to be.
Would it make sense to put read-only span char for that in case that changes?
The problem there is that my expectation is that there will be a lot of cases where people want to get the string out. Right now, we don't have a way to like. If we have a span wrapped around a string, this is the thing I was concerned about. Is like we have a span wrapped around a string, then you to string it again, you've just created another string. You didn't have to.
No, I think we talked about having an API that allows you to get back to the original string, I believe.
It's always legal to go from a span to a string. You just might allocate, right? So
Yeah. And I think that's pretty common for people to want to do that.
Yeah, but it's a hacky API.
Not necessarily. Like you could imagine that we just
try get string,
something like that, or like we just allocate.
Well, I'm sorry, I'm confused. Like if we had read-only span char right now, they did two string, they would not allocate, right? But you could imagine some, because you've already got the string, but you could have imagined some.
No, if you do two string, you will get an allocation.
Even if it's backed by a real string.
Yes, that's the problem.
Well, we don't override two string, I believe, right? Do we?
We don't.
So you guys must have discussed that and have reasons.
Because we can, right? It's because it would only make sense on read-only span of char. It doesn't make sense on, let's say, span of byte, right? So the thing is, we would probably have to have an extension method that sits on read-only span of char that's like get string or something, right? And then that one could do the right thing, right? Which is if there already is a string, I give you back the original one. If there is, if there isn't, then I just allocate one.
This is going to come up again, right? Where we don't want to bake in yet more strings into our API.
I mean, so the one problem is it depends on what you expect customers to do.
So the directory is the only one. The original directory and original user directory are what were passed in, right? So that's the same string all the way through, or set of strings.
I think the question is like, I mean, like what is true is that we don't have all the APIs that string has, and we'd only span off char. We never will. So it depends, I guess, also on what you expect customers to do. Like if the majority of people end up having to create a string anyway to do what they have to do, then you don't get much by that API. But I guess in this case, like what will people do with the directory? That's just like probably they base most of the decision on the file name, no?
Well, they can do it on both. So that one I'm fine with doing the read-only span around it and like dealing with the fact that like there might be an extra allocation there.
But let me first understand. So the directory, is it a combined
No, it is the combined. Like we need to give a contiguous file name to Windows, at least in Unix as well. We open a handle for the directory. We need an actual span of something, right, to do that. And it's very hard to deal with that out of like building it up on the way.
Basically?
It is the full path to the directory that thing resides in.
Just directory. It doesn't include the file name.
No.
It's a full path to the directory. I see.
Sorry if I missed it. The find data, that's going to the predicates, but it's not what's ultimately emitted from the enumeration, is it?
No. That's the transform. You get this is the set of like data where with minimal actually there's very little allocations.
One of the tests we have for putting span in an API is it's relatively advanced, or at least it's really important. Right, where this does seem a relatively advanced API. If I'm writing a callback,
yeah, this is an advanced API.
Completely appropriate.
Yeah. I mean, we can add another span here. I'm fine with it with directory. I just like that one I waffled on a bit because it's really hard to write the underlying implementation without like allocating a string.
Well,
but I
is there anything lazy here, like the
yes.
times?
So on Unix, some of those will be lazy, including the file name.
Can you make the directory then also lazy? The C# string. Would you be able to make the C# the directory string also lazy?
No, because we have to like get the directory handle open to begin with.
Okay.
To get the data back for like the files that are involved. So I'm fine with that one being a read-only span. I was just like was trying to juggle like whether people would want to be actually using that string directly.
But I assume the instance is shared between multiple instances of this. Like,
yeah. So like you have 1,000 files in the directory, you'll have one instance of that directory string. That seemed to be a reasonable. So like even in the large data sets, I'd look at our enlistments from desktop and stuff, and it like you might you can have thousands, but like you have like 600,000 files, you have 10,000 directories, right? Or 5,000 directories.
Like what's the lifetime? I guess there's one find data, right? Because you pass it by ref, right? So in theory, if you would have one buffer that you use for the directory, yes, you have to call Windows with contiguous memory, but you could basically override the directory every single time you do a traversal, right? You could reuse the same read-only, the span of.
Yes, and like I looked at that. It's more complicated than you'd think, but like there is some possibility that we might be able to get that far. So I'm fine with doing that. It's just like if you do need to get that out, it'd be really nice to have the ability to unwrap a string if we already had it in there. But if we have the read-only span there anyway, I mean, people should be thinking through that process anyway.
If you wanted to reuse a buffer between different directories, the buffer would be different length.
Yes, and it's hard to do that.
And then you cannot unwrap it because there's no string. You could have actually, instead of allocating a string, you could allocate a char array. You could allocate it longer than it has to be. You could then share it between all directories.
But the way you go through the directory, so like they get put on a stack basically. Yeah. Like everyone we find, we put on the stack and we keep popping them off as we finish a directory, and like that's why it's a little awkward. Like if I just create a string for that and put that on the stack, it's pretty simple, right? Trying to make that work when you don't know which way you're going down is like. Or what results you're going to get back out is a little hard.
Buffer seems nice, right? No, because you should be able to just strip the last thing, rewrite the.
No, you don't know where it's coming off, right? It's hard. It can be done, like probably, but
this API change now that can be deferred as important.
Yeah.
But the point I was trying to make. So if you ever want to do this optimization in the future,
and I get it, and I can do that. So
then you cannot retrieve a string because you would not have a string.
Yeah, and I'm fine with this particular one being the read-only span because then there's also it's also obvious on the consumer side whether it's not backed by string or not internally. You should have to cache it, right, if you don't want to keep allocating.
It's a good point that we should have more convenient APIs that convert span of char to string.
Yep.
And you are working on this API stuff.
It would be nice to be able to unwrap one. I mean, a lot of places it's come up for the past stuff. Would be nice.
Basically extension method over span of char, because you're adding a bunch of extension methods over span of char. One that basically just gives you a string.
If it's over a string, does an extension method have access to that underlying string?
If it happens to be, in the slow span,
right?
yes. In the fast span, no.
So it has to be on the span. Should we look at the predicates?
But I think it's fine, because you would basically, I imagine what code would do is would get a span, and just compare it for equality or starts with or something like this, which we have APIs for, working with span.
Mhm.
And then when it finds something, then it could materialize a string. But span would give it a bit more flexibility, because imagine that you want to combine the directory with the file name to have a full path. When you have two strings, suddenly we allocate two strings so you can combine them and create a third string, versus if they are spans, we could actually just allocate an array of the proper length, because we know the length, we have those two spans, and then copy the data into and give it the string.
Those APIs are implemented now, by the way.
Right. We need to
open code in them.
another option we have is
The path combined span is just waiting to get through the
we
last
even
bits of
need
it.
directory at all?
Huh?
We need directory at all? Could we also just hide it?
No, you need it.
What does the user need?
Use it because they want to make a full path.
Well, that provides uniqueness for this thing. Otherwise,
What is foo.text? Foo.text where?
Oh, because they have to,
The original directory and the original user directory are used for building up output strings. Like right now, if you pass in a path that's relative, we give you back. So this allows you to provide the same sort of behavior that we have. We don't give you back a full path. We give you the relative path based off of whatever you passed in.
Path on there returning span that would not allocate, right? Because it just beats a span over two spans. Whereas path combined is a bit more complicated than that, I guess.
Path.combine?
I'm just saying, could you put path on there that returns read-only span and it would not cause any allocations if I got it? Because it would just be a span over the directory / file name.
Oh, no, we have to allocate because they're separate. Those file names are just they're sitting in the struct, right? So there's a Windows struct in the Windows side or the other one. So the other one, actually the Unix side, is more complicated because it's actually what I'm going to change it to is I'm going to keep the original data as UTF-8 underneath the covers, and then allocate on the fly when you ask.
I guess what I'm trying to say is I could easily write a path getter on there that just returned path combine span, couldn't I? I mean, just be a helper.
We already have that.
You cannot just bridge two spans if they're non-consecutive.
Oh, you're talking about we can't have the span has to be contiguous. Yeah, sorry.
The other way would work. If you had the full path,
yes,
you could just return the file name by
Yeah, but we don't have that's not how it actually works underneath the covers. The fundamental one is you want to be looking at file names, and right now we do all this combination of paths that allocates like crazy.
So the constructor of find enumerable will also take a read-only span of char instead of the string directory.
Huh?
The find enumerable constructor, it takes a string directory.
I could. I didn't think it was that critical because
There's only one of those, right?
Yeah, I didn't want to get too complicated.
Is that identical to original directory?
Yeah, that is what original directory is.
Well, you have one per query, right? So
Original user directory. Then we resolve it, and that's what the original directory is. The original directory is the resolved one.
Okay.
And the original user directory is as you pass the string in, right? So
it's usually one.
Should it be root directory rather than original directory?
I think that's actually a good name.
That's reasonable. Root directory and root.
What's the difference between user and non-user?
Original, huh?
What's the difference between the user and the non-user?
One is the user is as the user passed it in, right? So it's the exact same string. It's not.
So the user one is the original one, and the original one is the root.
They're both the roots. It's just then we take that thing. If you pass in C:\foo, they're going to be identical, right? But if you pass in foo and your current directory is the C:, then one is going to be foo and the other one's going to be C:\foo, and that allows you to build up results like we do right now, which is gives you the results all come back as if you had passed in foo, then you would get foo \, you wouldn't get C:\foo.
Yeah, root user directory to me doesn't say what it does. It sounds like it's root directory instead of root user directory and full root directory. Am I understanding right?
No. The user means it's literally the thing that you passed to the constructor.
Right.
This is the original directory.
Right.
So we could say
It's not true.
we could say user directory and resolved user directory or something original.
Why not original directory?
I liked original directory because that tells you it was the same exact string. Yeah, original directory and resolved directory. Original directory and root directory.
Original root directory.
Well, what about resolved?
Resolved is not a string I've seen in any path API.
Yeah.
Is it not there?
What would you call it then?
Resolved is something we want to add. I guess that's true.
All is the only term I think of.
Is it actually full?
So how about original full path? That's what we've been using for everything else.
Well,
Full path
Well, but then we should.
or full directory. It's awkward.
So if we do this original full
I
path,
don't
then
like
you,
full path. Should have said resolved.
Normalized.
Normalized, something normalized or whatever.
It's what you get from applying get full path to original path.
what is it called in Win32 APIs? Those two concepts.
Get full path name.
I wouldn't look at Win32 for consistency and even for those concepts because they're really not.
That's where our names come
Good to know.
That looks pretty good to me.
Original path,
Name
original
and
full
path,
path.
for example, we also
That works for me.
Okay. Should we look at the predicates, maybe?
One other question about we are using datetime. Why you don't use datetime offset instead?
Because I need to talk to you.
Go for
So you
it.
got it.
So also, when do you create a? Is it,
I'll talk offline with you about the implications of that. I don't really care as long as we don't have to we have to convert it from the native stuff anyway. So
when do you do the conversion?
that one as it comes back because we're on the Unix side it requires another API call, so we don't do it until you actually get the property.
But I don't have to convert from epochs or whatever, right? You give me a UTC.
Yeah, UTC. Right. I tried to be very explicit about that and always say UTC, so there was no.
I recall on Mac we had difficulty to get the creation time.
Yeah, so that isn't always there. So
what
I was fiddling with the last.
you need to know, I think right now we have it set to nothing. We would do the same thing that we do for the file info. So it's really you're
on Mac, but not on Linux. It's Linux that doesn't have it.
Mac has it, yes, that's right. So Mac has creation time. Linux only has it on some distributions, but it's birth time is what it's called on those ones. But
And then length is the size of the file, I suppose.
yeah, so that may not have a value either, depending on what you're that may require an additional call. So I mean, I'll call out those things in the documentation about things that were potential overhead pieces.
This is kind of a basic question, but do I get this for directories as well as files?
Yeah.
Yeah. So if I just wanted to look at directories, I just have a predicate that dropped all the files.
Yep.
I can't ask for that.
So how do I know it's a
I
directory?
mean, I can't give you an enum like ignore accessible saying ignore files.
You need a predicate.
Would it be worth having an enum like that? Or
No. It gets too It's awkward.
What does length mean for directories?
Huh?
What does length mean for directories?
Nothing.
Zero.
Zero.
So minus
Last access time and last write time need to see also be a datetime offset.
Yeah, it should apply to all of them.
I want to get with him so I make sure I'm doing it right. But basically this is file info, right?
Right.
It's the same exact stuff that's explicit file. That's without.
So speaking of which, I'm not super thrilled about the name of the type.
But find data.
Yeah.
You probably wouldn't have liked my original one. I called it raw data to begin with.
Raw uncooked data.
Yeah.
Because basically it's a data about an object in the file system. It would be nice to convey it and not just like some generic find data.
It is pretty generic. That's true.
Can be file info.
No, it cannot be filing. Well,
But file system is what we call it. We call it file system data.
What if we call it filing for T? The name is not taken.
File info of T?
File info is taken, and file info is only for files, not directories. File system info is for.
Yeah,
system info.
something like this.
File system data.
I can call it file system data.
It's different than file info because file info is such a rich type. It lets you do operations.
What?
File info.
Oh yeah.
And this one is basically just a data holder.
So I'm fine. I'm fine with file system info data.
That's too long.
File system
But it's
data.
long.
What's the root API called? Because it's like a helper data structure for the root API.
Yeah, what namespace is this in? Just system.io?
Yeah, it's also system.
Yeah.
So,
Although there's been feedback that people would like it in the.
I think I would consider hiding it because it is pretty advanced. And when I'm trying to use a file system info, the 99% case, I'm going to get confused by the file info data.
So before we go there, my first question is how do I know whether it's a directory or a file?
This one, well, you have to look at the attributes.
Or the file attributes basically tell me directory or something?
Yeah.
So it'd be easy to have his directory helper on there, right?
We do have that, yes.
And it's an enum, correct? File attributes.
It's
It's the existing file attributes.
Yeah.
I had a question. I thought in the earlier iterations we saw an int pointer for the original file handle. Did that get dropped, or am I mistaken in seeing that?
So I don't want to raffle too much on this, but like my intent is to eventually provide more. Actually, that one I can do. Sorry, that I'm fine with. No, there's no handle. Never mind. That would only be for the directory. You don't have a handle for the file itself. Okay. But well, you have other stuff like inode information and things from Unix. Right. There is a plan to like extend this later to like have like the ability to get a platform specific set of data.
So,
but this is that's a whole nother level of
so
crazy.
What do people think about calling this type file system data? Sounds good to me.
That I'm fine with.
File system entry.
Right? Yeah, but it gets longer and longer. So
right, but file system data means that like I'm running on NTFS.
Yeah, it's right. It's too bad we call it file system info, isn't it?
I mean, we could call it file system entry with all the data, because I mean, I don't think the data adds much.
Okay. Right. Yeah, okay. I like it. That's one.
T, obviously.
So how do people know what they can pass to the
anything.
The state? It's T state. That's anything.
What?
Whatever you pass in, whatever you want it to be.
No.
Yes.
Object strings. Yeah.
Why not?
Really?
Yeah.
What do you do with it? If I pass you...
Well, the normal case is like you're providing, like this, the most common case is you're providing a filter, so they could be straight. You're providing star.cs. But you may want more complicated scenarios, like some of the build things where you like already have some sort of caching mechanism and you want to be looking stuff up within that and populating that cache or changing the cache based on the information that you fall back in. So they can wrap that plus the filter plus this plus whatever.
Maybe I don't understand how the state.
You could also have cancellation in the state.
So I think the way this works is, I mean, this is the other question I had, is like do they actually have to be on the state? Because it seems to me like all you do is you just pass it back to my delegates, right?
Mm-hmm.
So given that you already passed me this, why wouldn't you just pass me another argument with my state? Because that's much more consistent with how we do callbacks.
Because you want to have it traversed, right?
Yeah, but you get called for every single layer, right?
Domino is we have a notion of a path table, where because we have to store millions of file paths, so we just store it as a tree structure.
Right.
So that way we can just pass it along and keep adding it with the current context, and we can pass the state as it traverses.
Well, he's still saying pass the state into the predicate, just as a second parameter instead of on the...
Then you need to return a tuple as well, so that you can pop it back on the stack, right?
Well, you never return them, right? Basically, the only thing you return is whatever your transform stuff ends up being, right? Like, find data is the only thing you ever get passed to you. You never return it, right? And so when all the sides where it's passed to you, there's a separate argument that gives it the state. It's exactly as expressive.
And it would have the same stack semantics. It will allocate another stack.
Well, I mean, like it's called, it's part of the callback, right? So it shouldn't result in like differences in terms of stacking.
In that vein, couldn't it just be captured? Why do you need to pass it?
No, I had it off of the state.
Like it's just like
I had it as a separate argument that I got asked to put it on it, I think.
But why have an argument at all when you can just capture it from the outer context?
Huh?
Can't you just capture it when you create the predicate?
You're assuming you're always using anonymous delegates.
Yeah, you don't want to do that usually.
Okay.
That's the same reason why we have our delegates, where we basically allow you to pass in the thing, so you can basically have a static method that you bind the delegate to, rather than a closure every single time you iterate.
Forgetting why I was asked to put it back over.
So the reason I would make it separate is to basically separate the file system semantics from the enumeration traversal walk, essentially.
I'd keep it separate.
For enumerability to be useful, if you could have a different state object for each subtree, because there is some data that we need to propagate through the traversal, like the remaining wildcard directory or remaining applicable excludes.
So you could wrap the state in another state and keep passing it, right?
Yeah, right now I'd have to keep a dictionary from directory to the state.
Would you? Or would you just have to intercept at each of those levels and rewrap the state? But you'd have to do that anyway, right?
We have wildcards for directories as well. Like we have a star.cs, but the directory part could be bin star / foo / obj star / something. And then as you recurse, you need a pointer where you're in that big path.
Yeah, and you can track that either by like doing the string compares for one, because you know which directory you're in and which your original directory was, or you can just add that to your state object, right? And just modify your state object as you're going along.
Well, that's one of the reasons why I think having it as a separate argument makes much more sense, because then you don't have to do that. You just pass it in, right? Like if you look at this code here, right? I mean, you pass in the state as you're into the root I enumerable, right?
Yeah.
If you want to do any sort of recursion here, well, I think it's much easier if I can just effectively pass in the state as a separate argument than me having to mock with the find data to just override the state.
That's fine. I can't remember why I was asked to put it back, but I'm fine with pulling it out.
Because everything else on state is basically read-only. That would be the only thing that would be then read-write, which is kind of weird. And then God forbid the user doesn't really own the lifetime of the object, which is the other problem.
Yeah.
So then they would, because it's a ref struct, right? You basically would, everything is basically would change the global instance that you passed on the stack, which is probably also not what you want. So you would have to copy the struct, which is now even more lines of code.
Fine.
And just keep passing the separate argument.
I have no arguments with breaking that separate.
Yeah. Another use case for having a different state per subtree is Angular you can pass in many excludes, but not all of them are applicable everywhere. Right?
Yeah.
So as we descend into the tree, we only pass the remaining number of excludes that seem to be applicable or will be applicable in the future.
You start filtering.
Yeah. Because it's expensive to ask all the excludes each time. Do all of them apply, right? So we reduce them as we go down. So now we're going to keep a dictionary in the state, in a global state, instead of when you pass in the recursive or whatever. When you recurse into the directories, you just pass a new state object, which is applicable only for that subtree. It becomes smaller and smaller.
Mm-hmm.
Maybe there could be an overload for the recurse predicate. It also gives you a new state object back. And that one gets injected as you traverse. But if you don't use that predicate, then you can just use a global state.
Yeah, because this is all global in this case, really. That's why I was asked to put it back, because it is global.
So the structs that show in APS as input parameters, correct?
What's that?
Yeah, input parameters. Those structs. That's what Emo said. Emo said they are only ever passed in.
Which struct?
The struct that we are talking about.
The find data struct, which is our new name, but
Yeah.
So find data is like, yes, you never get it. That's only inputs to the predicate. It's just basic. It's basically an adapter onto the native data that deals with the headache of like trying to get safe access to the buffer and do lazy initialization of the data for the cases where it matters on like units and stuff like that.
Just a question for the MS build, they want to skip some folders, for example, but find all, for example, .cs file beneath their folder, but exclude certain folders.
Mm-hmm.
For that API, it looks like it was still scan through all folders. They match the direction and skip them. But you cannot skip folder by its entire folder by one operation.
You can skip the folder. That's what the recurse predicate is on the find interval. It's just the I think it's wrapped off the side. So there's find transform from there, and then there's find recurse predicates the next one.
Oh, I see.
So some of the options we might add in the future is like controlling exactly how we recurse. Like we might be able to provide the ability to do depth first or breadth first as a explicit thing, which might be able to allow you to optimize.
Okay.
Those sorts of things like.
And then for breadth first, you could have a state for the entire level.
Well, so those are the things we can. Well, you can make assumptions if you've got other things, right, about like what you're doing in your internal state.
You would basically know that before they call the recurse one that you have seen every other file in the directory.
Yeah.
So you can accumulate state and then say, based on the things I haven't seen, I can decide whether I want to traverse or not.
Well, right now the state is. I mean, you get everything in the directory before you get any other directory. So the question, how it goes down from there, like it's depth, but it's not. So you get the entire set of files for a directory, and then we just start popping off the things we found.
Sorry, it's every level. Yes, that's true.
So, but there's ways we could tweak that too, like in the future, like that it enables better scenarios.
That's what you say.
So the find predicate. Why can't you use just the predicate that we have in the
Because it's a ref struct.
So find data is a by ref struct, and why is it a by ref struct?
It's not a by ref struct, it's passed by ref.
Passed by ref.
Right. So this is the problem.
So it's not a by ref struct.
No.
Okay. So
sorry.
Should we add to the BCL ref predicate?
Hold on, why is it not a by ref struct? You hold on to a read-only span of char, right?
No, you just return it internally as a native buffer or an array or a string.
Yeah, so it's a property on there. It's not a member.
Oh, I see. So
this thing can't come out. So like the find data has to be used while you're being given it.
Right. So should we add ref predicate to the framework? Because it seems like basically you created a predicate where the is passed by ref. That's only thing, but it's very general purpose.
As a first knee-jerk reaction, I'd say yeah, but I can't see right off the top of my head what that would look like.
How many would you add?
It would be a predicate that's called ref predicate. And it takes
how many
T by ref. One?
You have one for
Can you do that for
We
start?
only have one predicate in the framework.
Yeah.
Takes T and returns.
Well, that's true. You only have one predicate. But like this one, for example, if you actually change it to like accept the state, what do you do?
It doesn't accept state.
Well, that's what we just talked about, to extract the state from the find data.
That was why I was asked because
you parameterize it when you on the call side. You parameterize it. The T is find data of state.
Well, that's what I'm saying. Imagine we separate the state from the find data,
and then you wouldn't be able to use the ref.
And basically say the predicate basically changes the signature from what it is today to ref find data, comma T state. Now the single predicate no longer works. And then the first argument is ref, the second one is...
lines of why I was asked to put it on it, actually, now that I remember.
And where is the state passed? It's passed to the constructor as well?
Yeah.
At the end somewhere.
Right. No, what's the first thing? No, it's actually in the end, yeah, you're right. It's like...
You can zoom out.
I could, but then here it is.
So if we added ref predicates... There's a ref. I don't know. Do we have anything that matches transform? I don't know. But it would be nice to have ref predicate rather than adding additional predicates.
Honestly, like to me, the value of unifying on delegates is much more profound when you're likely to combine multiple things, right? Which is basically more like a link style scenario where you have already a func of something and you want to compose it with something else. This doesn't strike me as an example where that's very likely because your transforms are super specialized to your current use side. So, I mean, you're not very likely to have the wrong delegate type at your hands.
Sure.
Well, if an API has func, I already know what to do. I know what a func is. Whereas if it takes find transform, I have another cognitive step.
Well, I mean, the nice thing, it cuts both ways, though. Right? Like, imagine, ignore the problem with ref right now. Let's say we would just use the generic links or predicate signature in the framework. Okay, predicate, we could use predicate, but then find transform, we would say it's func of t result, func of t state, t result. And it's just, at the call side, like in the APIs that take it. So right now, there's no name type anymore. So you couldn't put any documentation on what the expectation for the delegate is because you have no place to put it. You would have to put it basically on the constructor of find enumerable, essentially. Versus if you have a find transform thing, you can actually document it in like what you expect the transform to do, and like.
I would
for the transform.
There's another document I have to read. Whereas if
find transform, you kind of have to because like you don't know what you're expected to do, right? You have two objects, and like what are you supposed to do with it? The other one, I get it because a predicate is a predicate, but like. It's like, do I want this or not?
So let me ask even like Papa 11. The constructor looks super complicated.
It is.
It's very long. It takes many things. It takes delegates that have kind of strange names. Did you consider any other way to design the API? Like, for example, one thing I can think of is it's an abstract class. And you override the member code, it is match, and it takes whatever parameters you want, and you don't have to use delegates, and then you basically, to use this type, you have to inherit from it and override the methods that do filtering, transformations, and some other things, and then you use it.
I did, but it was a little bit more awkward to build to compose in that case. Like. Bits and pieces of solutions from other people. If you're already like forcing them down this predicate path, then you can like combine another predicate on top of an existing one.
And what are the existing solutions?
There's some in here, like just basic things like.
Look at this here. For example, you have an existing predicate that says, like if it's a directory, I want to take it. Or if it's not one of those magic file system entries like dot and dot dot, like you can't compose them, right? They're abstract classes.
No. I mean, these things would not be abstract classes. There would be a task. You override the method and you say, is directory. It's an extension method on find data, whatever it's going to call.
Well, that works, I think, somewhat well with the predicate. I don't think it would work well for the transforms necessarily. Well, I guess it's just a function.
You can look at the transforms and see, but like.
No, that's right. You can always call the function that does it.
It's kind of like, APIs, especially when they take many delegates, people use lambdas. There's always like the issue with captures, accidental captures that you would avoid if you inherit. There's also an issue with like the compiler gets really confused if in a lambda you have a syntax error, and when you have 3 lambdas, there's going to be so many brackets.
Yeah, I mean, like I would say I tend to agree. Like, I mean, the thing with abstract classes, like. It does look more heavyweight at first, but I do think it allows you to document the bits and pieces much more easy because it basically avoids global predicates in the namespace. It avoids nested generics because basically you only have the root type that's perinumized and everything else just gets signatures.
I mean, we'd have a lot of types basically is what would happen.
Well, you would only have the abstract.
All the scenarios that every time you would like come up with a different enumerable set of conditions, you'd have to build a whole.
You only have one. You would have the find enumerable that you already have. That's abstract, and then the users would have to derive from that. And all the built-in predicates you currently offer, you would just make them either instance methods on the find enumerable that implementations of that are supposed to call, or you make them top-level extension methods somewhere on the find data. Right, one of the two.
But whenever I have one of these jobs to do, then I'll have to make a new derived class from the abstract class.
Or you can make
filling up the list of types in my assembly.
Or you can make yourself one that just calls your delegates inside the virtual
machine. It could look like that. You could just cut the middleman.
But so the point is that I think that like delegate-based APIs, they work when they are simple. Right? There's an advantage. I don't have to inherit from a class. I don't have to override anything. I just basically, call it with one lambda, and I'm done. The moment, there's, I think, a line at which point when there's like 3 lambdas with complicated parameters, it's like it may be not that much more usable.
Yeah, if you look at code like this, like basically you have to read documentation to figure out what the line is supposed to do.
Sure.
Like imagine instead you see, internal field class, my full path with extension extends find enumerable, then you see, override predicate, override transform, and you basically see what the bodies do. Like, I mean, the code almost explains itself, right?
And I bet if you miss some syntax symbol, the compiler would get so confused about this one.
I'm not sure you'd have much more help on the overrides than you would when you hit comma there and see what the parameter help is, would you?
Well, so I think that one of the problems you have to consider is that as soon as you have like a few generics involved, like especially with delegates, it gets complicated quickly. Like, I mean, just like open IntelliSense on Link and see what IntelliSense shows you. You cannot read the API signatures. Like, it's impossible. Like,
no, but the thing I was talking about is if you have a syntax mistake with the neo lambda, the compiler often cannot infer the type of the lambda.
Yeah,
and if it cannot import the type of the lambda, it cascades. It gets confused.
So what is our base class? What does our class have right now? It's like this is just T state, or does it even have that?
T resolved at T state.
It is T resolved T state. Yeah. But the enumerable, yeah. So we're already creating one inning. I mean,
I don't know. I go back.
That's my only. We would have a bunch of those potentially in the future. That would be the only thing that I would be.
For what?
The framework is we provide the additional, like, instead of like just one method added on somewhere where we have another some other set of flags to like enumerate in a special way, like with like the type of filter that you're going to use, right? Are you going to use the simple filter, or are you going to use the DOS filter, or are you going to use the regex, right? Stuff like that, right? When you're calling the existing directory get files or whatever, we have an overload that allows you to specify the filter.
I'm not sure whether.
So, each of those would have.
Depending whether we use delegates or virtual methods, because the virtual method is basically just the same thing as the.
Yeah, just hidden. I mean, just like you just have a whole bunch of these things floating around that are like find enumerable of these two combinations, right?
Another thing I don't know if you guys
there
care
are these
about,
three states,
but the virtual methods would be also more kind of potentially faster, because here enumerator, like you have to create an enumerator, correct?
Well, I do the same stuff we do the other one. I don't. The enumerator is itself.
What? You have to create a numerator because you return an interface. You cannot avoid creating an object. The enumerator?
The find enumerable itself is the enumerator. It creates a copy.
Do the same on dictionary and things.
We do the same thing with the existing one, right? So like it passes back itself as long as you haven't.
I see. But then you have to
on subsequent calls. Yes, if you reuse the same enumerable to iterate again, then it would have to create another. Yeah.
And also you have two calls to get an item. Get the current and move next.
True. That's that other thing that was come up, right? That was the other discussion.
Complain that it doesn't use the API that doesn't exist yet.
Well, then I guess in either case you could add that one. It would be nice to have the debated enumerator.
Enumerable too, with
make two function calls.
Sequence, but yeah, effectively.
To move, then get the item.
There's one method, try get next or something.
It feels weird to me to define a type for a job that I just want to probably do in one function and then have that in my namespace. It just feels odd. Like I want to have a class nested in my function.
But I mean that's the thing, right? I mean, like I think the thing I would say is if you look at the sample code here, I wouldn't call this is the one small thing I'm wanting to do. I mean, like you probably spend like half an hour coming up with exactly those 10 lines.
Yeah, well, I think I would define each of the delegates as variables rather than trying to do everything in one colossal statement.
Well, there's weirdness around this in the performance of the framework, right? Like, if you want to get this thing to cache the delegates, you have to do it like this.
Really?
So, yeah. like if I just had the methods called in, that's why it's uglier than it like has to be otherwise. This is the best practice right now. This caches the delegates. Like if you just pass find transforms as full user path.
You're saying if you have a local, then it wouldn't cache it. But if you create a static global, then it would. What do you mean? So basically somewhere else in the global scope, I just.
Well, I think what he's saying is instead of replacing the contents of this line with just this, which is legal in C#,
or a variable belonging to that.
You can always replace a delegate with its corresponding method group, assuming the signature matches.
That doesn't get cached.
It doesn't get cached, so basically.
Yeah, but I think Dan was not talking about that. He was talking just create a variable, store the delegate in it, and just pass to this constructor.
That should still work, right? And if you take this whole expression.
Well, yeah, that will. You'll just hit performance implications with that because you won't get the but only for the fact that it won't get. You also won't get the cached delegate.
You don't get cached even though then it's a full.
If you've got a capture, I think it doesn't cache it.
Well, I mean, if you just take the string as it's there and you just assign it to a local before you return new find numeral statement, that should still work.
Yeah.
They should do the same thing. But, I mean, the problem when you do that is then you no longer get type inference. You literally have to spell out the delegate signature. Like, you have to call the delegate name. Right now it knows that it's a fine predicate. If you assign it to local, you have to say it at some point.
I can't use var, and it won't figure it out.
No, because the delegates don't have a type in C# unless you...
Just make a syntax mistake inside the body and then all hell breaks loose. Because neither the method knows what the delegate is, nor the delegate knows what, you know...
I'm fine with the other one. It's just we'd have to have classes for every combination where we surface. I mean, internally, like right now, I have.
Oh, internally. Okay, I understand that. Yeah. Okay.
So, like right now, we like as you see the surface, like everything is built on this right now. Like as we have our surface area right now, there's a variety of combinations of predicates and return data and stuff like. And now we would have like 8, 9, 10 find intermobile drive things that are like. Right now is just a very relatively simple. So like if you start building up complicated ones, like yes, the syntax here is like awful, but it's simpler than having 8, 9, 10 classes to look at.
Another thing that maybe it wouldn't completely fix the problem, but it might be hurt a bit, is if it was not, they were not parameters to the constructor, but rather like properties. So you create the enumerable, and then you can optionally apply a filter.
I think I'd be fine with that. I mean, the onus is on you, but because then you could use the initialization syntax, right?
Yeah, it becomes simpler. You don't have a constructor with 8 parameters, and if you make a mistake with one. Like,
would you take both delegates off the constructor?
Error checking would be a little different. I'd have to move that around. So, like, if you don't set some of those, you have to have something, right? Like, I need to have a transform. You need to have.
Why do you need that transform? We didn't yet look, so I don't even know.
Oh, because we have no. I mean, we can't get back the find data, right? We have to get back something. What do we get back? We can make defaults. I mean,
also, if you did it that way, I could change it during enumeration. I don't know if that's a feature or not. Change my mind while I'm enumerating the disk.
Well, I wouldn't let you do that. I would keep the internal state.
So what is
stuck?
What is the mapping that you just mentioned? What does it do?
There is no mapping right now. You have to be explicit about it.
Sorry, you just mentioned one of them. Transform. What does it do?
What does transform do? Yeah. So, like you right now, for example, like we provide out, you're getting file info, right? Because you're asking for files. You did it from directory info. You're enumerating file infos, right? So there's one that will turn that thing into a file info. It's got an optimized internal path that doesn't allocate as much as the old one used to, and like it gives back a file info for every result.
So you're saying you convert from the new type that we
the find data,
you can convert it to whatever you want.
Yeah.
So the default
file name, full path.
The default one would be identity. Like there's no conversion.
You can't pass identity because we can't give that back out because it has a reference to native data. Find data is passed by ref on purpose.
So if this delegate is null, so you will not do anything, right? What will happen at that time?
Well, you can't get back a result, right?
Well, you still enumerate and will not get back results because you didn't set it, right? If you want to get
What does
results,
current mean? I mean, what do you get from current? Default of T? I mean, you could, but one way I had approached this when I was prototyping, trying to come up with a solution for this, is like I actually had it have defaults. So, like, if you didn't specify, then it's full path, and it's a string. And I had to look through the type of the output and say, like, if you ask for one of these types, like the normal ones, you ask for file info, you ask for directory info, you ask for a string, and it just ended up getting complicated, right? You have all this logic and the thing to like try and pick something, and it's a little hard to like go back and track. I mean, it kind of works the way you expect it to, but like it's a lot of logic in the constructor and doing type checking and stuff.
Do something super trivial, like just return the full path. That's the difference.
But you can't, right? Like, what if your return state is file info?
No,
right.
I'm saying by default.
Right?
What if your return state? What if your return state is my struct, right?
Right. They're not strings. Could be anything.
That was another part of it too. Like that's where kind of what you guys might end up doing in some cases, right? Is like you want to like get bits and pieces of that data and associate it with some state that you were doing internally, right? So, like, what's the current position in the state, right? You know, so they have a struct that gives back out the string plus the position in their state and some other. Like,
but there's maybe bear with me, maybe I misunderstand. What I was saying is, you know, the delegate would still take fine data, but the default one would just extract the full path, would allocate, and give you full path. If you don't like the behavior, you change it and you do whatever transformation you want.
the T result is anything. It can be string, it can be file info, it can be my struct, right? That's the problem.
T result in which method?
For the enumerable. The enumerable will give you back anything you want.
So the type you're passing in here, this one here, is the return type. Sorry, that's the state. This one here is the return type of all the predicates that you're constructing. So the user constructed, like, let's say it says int.
Yes.
Well, you cannot just return the full path because the types don't align. Right?
Well,
Which is entirely possible that they may want ints even, right? You look at the Unix side, you know, you build something on that, as we have the other stuff you want, get back out.
Let's just say you want to count the number of files.
Somebody parameterized it with a delegate that returns as, string array, so it returns string array. I'm saying by default.
Maybe I don't understand what you mean by default. Like what do you mean by default?
It's like asking what list of T should return.
By default, yeah. It's like, well, it's T, so whatever that T is. Right?
See, what you're saying is because it has it's a type parameter on the type itself as well.
Yes.
This is enumerable of T.
It's quite common that I wouldn't necessarily want to filter. I just want all the files out of some directory. But what do I pass in? A null delegate here, or is there an overload, or is it specialized such that there's a null? Well, I don't know.
So if you don't provide those key ones, I can see the other ones, the optional ones, moving those to parameters, right? I'm fine with that. The other one is like the error case becomes weird because if you don't have the necessary, you need a transform. The filter can, like, fine, you can make that always return true or something like that. I don't know if that's the best decision, but at least the transform you have to have. And if you push that off to a property, then you would throw when you actually start enumerating, which.
So maybe it's just, the constructor takes one delegate for the transform, because the transform basically tells you what is the type of the thing that this enumerator creates.
And it does the action of actually.
So you kind of.
I wouldn't want to make that default of T because
so
that's
you
bizarre.
have to do it in the constructor.
But the other ones I'm fine, like even state or whatever else.
So what are the other ones?
Set.
The other one is the filter.
State you don't care. State you may not care about.
And the other one.
If you want to get all files, you don't care. And actually, the behavior of the filters that we have right now is like null gives you everything. But, so yeah, I can move off the ones that we don't have to error check up front,
Which is the last three.
which have defaults on them anyway, right? So
A good question.
sure.
Do you have a plan for making like the real super common ones easy for the programmer. So the programmer has to pass a delegate for find file info. That's going to be easy. I don't care how.
This thing is intended to like it's to be like a two-stage thing, right? One is that, like, this opens up everybody's or a substantial chunk of like what people want to do without having to have us write a higher level, nicer API on it. And the hope is twofold. One is that people are unblocked, but the other one is that we actually see that like the same people are writing the same chunk of helper code. We say like, well, this was done here and here. A lot of people need this. Let's add another API to the root surface area that's easy and like isn't as configurable, but gives you that particular scenario. Okay, so right now that's been second guessing, right? Like we go like, well, we think it's like this is what like how many people need just the file name? This was one of the examples I gave at the beginning, right? You know, like that could be a lot of people. It could not be. Like I can guess, but the proof in the pudding is like looking at what ends up in people's repositories.
But I think like the short summary is we're not proposing a new set of file APIs. Basically, we're not going to replace the ones we already have.
No.
Because the ones we already have, I think, are hard to beat in terms of usability, but they're allocated, right? They're not very they're not very performing.
That's why I was asking the question.
I think the number one thing we need to fix in our APIs is not the perf. Is, as Jeremy said, it's the thing that when you recurse recursively, and we cannot access one directory, you have to do everything yourself because there's no way for you to basically handle errors because we don't do anything, right? So
and that's it's semi-orthogonal to what we're doing, but it's also related, right? Because like I'm actually providing that now, but this is the sort of thing because we're built on this internally. It's relatively in like the parameterization that I have is like that's one of the ones I offered right off the bat is like look, ignore access denied, right?
But I actually think that this API, like this type, would have static functionality that create kind of pre-cooked enumerators that are as usable as the existing API.
Yeah, eventually, but like
basically just file enumeration, whatever this type is called, that create file info enumerator. Right. And it now gives you basically an enumerator that gives you file info or file path enumerator, and it gives you strings that are the full path.
And then that's what I'm kind of expecting is something along those lines. Is that like we'll have those wrappers for the common scenarios built up, and then you just go. And like, but I want that to be more data driven by like not just like we're looking at what people are voicing opinions about, but seeing how things actually get written is used in other code is like. Just that much more, because like the other thing I don't want to do is have an explosion of stuff that like is not very broadly usable, and that's a difficult call to make sometimes, particularly with these things.
Do you have a location plan for where you're going to put those? Do you have the location plan for where you're going to put those?
No, I mean they may go like I haven't thought.
The design looks like that might be a little trickier than it needs to be.
They may sit on directory. They may not. Like what he was saying. Like we just need to look at those two. The gives and takes between those things.
Okay.
If we put this in a sub namespace, then that can change things.
I can live with you postponing. I think there's a couple that are so obvious. Maybe don't postpone them, but I think we could live with postponing all of them if there's a plan for where they go. But if you make just one, then you know where it's going to go and you have your pattern set, and that just might be a little more future-proof than putting that up front. So that's just a call to make. But it's, obviously you're not going to put it, or at least I don't think you're going to put it on enumerable FT,
No, but like, we'll see. It's definitely in the plan. It's like, I think it's flexible as to where it ends up going. But
I guess I don't like that because you're looking at something which would be very much part of the user experience where it goes, and so I don't think it should be like flexible up front. We'll figure out where to put it because it's going to be factory method, right?
No, well, let's say that's the point is we don't know. I mean, like it could be that we add more overloads. Right now, I'm a little hesitant to do that. I would want to be very determined about like where we start at. Like, I want to look at the options in great detail before we add our first one, where we add a new. I have one very simple one that we're doing is we're adding the options. You can see that, and that only gets a subset of things that we're looking at here. But like to provide pre-canned things, like I think that like we would want to take our time to think about to do that. Right now, we're not doing it, so this doesn't block any decision wherever we put this.
Yeah.
I honestly
the
think
only thing on that is that if there's a high bar to get into it, I don't believe that the metrics you're going to get are the right metrics. You're not going to get the right breadth of people doing the right breadth of stuff. If the bar is, and I don't know where the bar is, but I'm worried that if it's hard to write these because you have to write a lambda expression to use the find data, and when you get the thing out, that you say you're going to look in repositories to see how many people are actually writing this, and then that's the one that you're.
They're already existing like helper libraries that people are building, and that's kind of the. I don't expect like your average developer to be going wrapping these things. What I expect is that like some of the existing community things and all higher level abstractions and the more like you see people building things and things like that, then you'll actually be able to. That's a good indicator of what's going down. Like I'm not expecting your average developer to be combing for them. I'm expecting them to be asking some intermediate step along the line, right? Or more advanced users to be giving us some like seeing stuff in real world practice, and like he's like everybody keeps creating the same sets of filters and so like that will give us a lot of input.
I think honestly, if you look at this API, like the way I think we end up going, if you just look at the way our APIs are structured, they're basically mostly static helpers, right? And like if you think of it from a function standpoint, I would say we are at the point where adding more inputs to these methods is not helping anymore because they get like longer and longer and longer. And the biggest problem is that there's combinatorics. At some point, you're like, in this case, we just want to add find options. You see all the methods we have to add to make that.
Is that orthogonal to find option?
Well, search option is basically recurse and non-recurse.
And so find option is inclusive of search option?
Yes.
Sort of. The problem with search option is an enum, not a flags. So
we started our enum with 0, unfortunately. So
So what is find options?
Well, we look at it.
Yeah.
Yeah, you say that, but then I have to use this mouse here, so that may take a while for me to.
And why does find option need to be a flag?
Well, because you're
look at it and see.
Orthogonal concerns.
So we'll start right now. Is like we have recurse, use large buffer, and those are initial set. Other ones that like we've already discussed it, like this changing behavior of the way the enumerator works itself. So like it's very hard, for example, to like provide a filter for errors, right, in a generic. Right. That's just awkward between the platforms, right? Like so, that's where something like, well, this is a built-in functionality within the enumerator. Tracking cycles would be something that we would potentially add in the future as another one, right? So, because other APIs do this, right? So Java does that, for example. They allow you, if you actually do recursive, it will.
Are they gonna be all real flags when I can combine them freely? I a bit worry about shipping flags enums that then we think that we can extend because we ended up in the past in a situation where some combinations of the flags were not valid and some were, and then the user doesn't know which one is valid.
So far, don't have that. But again, this is like hopefully we can add, if we ever get to that point, I would try not to do that where they like are totally contradicting, as we're adding things. And if we do get to a point where some set of things are invalid, then those are the ones we can check, right?
But if it is not flagged, you still have the same problem.
Yeah, well, I in general, so I look at this enum,
right,
and use large buffer is kind of suspicious because what is large? You chose. So I'm thinking, in the future we will want to have more control, so we will add yet another parameter where you can specify the buffer size.
But I think that
it seems to me like this enum is fixing one problem, which is don't throw when you find an accessible file.
Sure, but it's a super common problem.
Yes, we should solve it, but I'm not sure whether enum is the best way to solve it. Is it?
I don't know of a better way to do this for the simple case.
Well, I mean, that's the thing. I mean, I could imagine that instead of having
a gazillion options is all, on the...
Well, instead of adding, like, find options as an argument, I could imagine that our high-level API, instead of basically being static helpers, is more something like a fluent API where you basically construct your query, and then at some point you just say, run. Similar to how your find enumerable works. but a much more convenient API for the high
I
level
was
usage.
thinking about something slightly like when he was saying like we want to extend it in the future, and it's basically, frankly, a way to specify a larger buffer. Why not a struct called, file enumeration options, and you have a field that says buffer size, and you have a field of ignore errors, and then you can add more fields in the future for whatever you want.
How does that help with the invalid combination problem? It's still a runtime error, right?
Well, it doesn't completely solve the problem, but it, for example, solves the problem of now I can specify buffer size that I want, and now like large buffer size.
That argument I understand. Like so, like you're saying, like being able to provide something that's more than just a flag.
Like structs basically that have like options flags. In the past, they were easier to extend than flags.
I'm fine with. I'm fine with providing a struct instead of a flag set. It's just that's the default knee jerk. I didn't see it as being strictly necessary to be able to provide the buffer size. There's some awkward. That one in particular is a little dangerous because if your buffer isn't big enough to get a single result.
If you said those are all the options that we will ever need, yeah, we had enough like this, but
yeah, one of them is search option, right?
I have a question.
Sure.
So for the CPS side, we actually constructed a tree, scan the disk, and then build an immutable tree structure. So we always, so the tree is built like we build the immutable structure of the subdirectory, then create a parent directory. So for this one, it's a little bit harder because I don't know when it finish one directory. I can use the next one to see where it's now scan a different directory to know the previous one finished.
Well, the recurse predicate.
Yeah, so the recursive one is.
No, I did that before I added actually. So there's no.
So we do that reverse one. We finish it. We take an action when we finish scan the directory.
You finish scanning a directory or the entire thing?
One directory. So we basically it's a deep first scanning, and every subdirectory return a structure. Then we combine everything beneath a folder to the parent. So it's an immutable structure. So we cannot insert and it will just explode the memory. So it's always constructed from leaf to root.
Okay.
So
you could add predicates for begin directory and directory. Or is that much?
Or a sentinel item.
Yes, currently we scan one by one, but it's kind of because that will just create extra structures.
I guess a sentinel would be.
When you do there, you get that and that.
You do actually in the beginning, so you know when you're starting. Like because they don't get filtered out in this case. You have to filter it out yourself. But like.
So dot is the end.
We introduce another one. Dot.
Or you could just have something on file info data that just says is first.
Well, you need
they want the last.
You need last.
Why? And you don't even know that it's last, correct?
Last one? Yeah, you know when it's last.
Really? How?
Because we have to move to the next directory.
Yeah, pop up.
When I'm about to pop the next directory, I know I'm done.
Do you guarantee that behavior over other platforms? Is that you'll go?
So there's a next, right?
Well, but
so like you get no more data. Actually, you don't know until you ask again for the next one.
Yeah, exactly. And you already called the callback on the previous one where the property would make sense. It's like this is the last item I called you in this directory. But
you can't do it. You have to grab the because it gives you a set of stuff, and like you get like however big your buffer is. Let's say you get 10 items in that thing, and like you get to the 10th item, and you ask for more data, and it says nope, no more.
You could always.
But it would overwrite the buffer, right?
Well, what you could do is
you could keep 2 buffers.
You could move next, store the previous, move next, and then do the callback with previous, and then replace it the previous with the one that you just moved to end.
But we're reusing this. I'd have to use 2 buffers.
Just wondering about like
next buffer. Do you have any data?
Can this API be layered about there is parts that enumerate just one folder, and another part was layer which is go recursive.
What you're asking for, sorry.
Yeah, go ahead.
But like his other thing about doing a base class would actually, that would be easy to provide in that case.
So another thing about the base class, one thing that I kind of learned not to do is create APIs in the middle. They are like neither optimized down to the metal nor convenient. And sometimes, like, you have to inherit, we are down to the metal, you have access to everything, you can do whatever you want with it. It's more, you can overdo it.
Well, actually, I didn't seal this class anyway, right? So, like, we could provide that level of some other functionality as well. So, like, a combination of the two.
The only thing I would not do, like, really down to the metal is lifetime. Like, if lifetime management leaks into C#, it stops being C#.
Yeah, I agree. But like this whole like finished enumeration, the finished directory thing is pretty simple. If you're putting it putting it on the state of an item, no. But like as a method call, as a callback, what you said was a callback. If you have it, you drive and you care about that.
Oh, because if they were virtual methods, you would basically, if you're interested in, I just finished the directory, this callback would be called. Yeah. Here you only have one call. Well, you could add yet another directory.
Which I wouldn't do because it will be but like a combination of the two, I think would work really well for some of these things. And I even considered that when you were talking about like some of these more like the recurse thing, right? Is like, well, maybe because the recurse thing, the things that you don't need all the time, like should I recurse, right? Like, well, maybe that's one I use as a virtual method.
I see how the abstract class beats the enormously long constructor, but I'm not sure how the abstract class beats the bag of data, where you just set properties on the enumerator.
Well, you could argue it solves the problem of having another type that holds the data because it could just be properties on that type.
Well, either way, I've got a type, right?
But the type already exists. Like find enumerable has to exist like regardless, right?
Right.
So instead of having another find option struct, you could just make them all members on that type, and then maybe make them protected sets so only the derived class can.
Right. So in one case there's two types, but they're both ours. In the other case, there's one type, but it's theirs.
Right. But like they derive from a type that's split.
But they could end up with n, right? Whereas with this way, you only ever have two.
Sure, but to me, it's about net. It's about net reduction of concepts and lines of code, right? So, for example, imagine like the predicate is a virtual function always returns true. Imagine that recurse is a predicate is a virtual that always returns true. So there's already two things you never have to override unless you care about that policy.
Well, this would be the same with the bag of state. You just wouldn't set the delegate.
Well, but then the problem with the constructors is like the number of overloads and combinations you have with them is like limited.
No, not a constructor. The bag of state. So the constructor just takes the directory and the transform, and then all the other predicates and options are set on the bag. That was the other proposal.
Sure, you could do that.
The only reason I think that way is I'm just thinking linearly. I'm starting to write the function, and I'm like, I have to go make a new file, put a class in it, or have a nested class higher up. Just feels like...
This is the second meeting in a row where the conclusion is we should just have types that are dictionary from string to delegate.
I was about to say, like based on Christoph's earlier argument about not being fully there and not being somewhere else, I think like C# tries to be more functional, but like this doesn't strike me as a functional API. Like this is a low level, potentially non-trivial API, and I'm not sure that a bunch of delegates is logically the way to model it. I mean, yes, you can. I mean, technically, every object is like, as Christoph said, like a dictionary.
It's probably the C way. If this was in Linux, it would probably be written that way.
Callback
function pointers.
But then again, like I'm not sure that's like.
And if we worry about the explosion of types, we could just inherit from this base type, create one of those, and it's a helper. So like, it's a helper on top.
What you're supposing having a type that accepts delegates?
Exactly. And calls it from those visual methods.
That's like, at that point, it's like, well, let's make a decision. What do you want to do? Like,
well, to give you kind of I mean, I want this thing to perform well with 500,000 files, right? So, looking at overhead for particular things, I was trying to keep it. I spent a lot of time talking to David and other folks, just trying to look at the give and take of calling
a virtual call versus a delegate call. Sorry.
Well, the delegate calls are actually pretty fast. That's not generally a problem. It's the construction of delegates that can be costly. That's why you want them cached.
A virtual call slower than delegate calls?
No, approximately the same.
But they're roughly the same thing. I tried looking at interfaces. That was definitely not the way to go. But
in some cases, virtual calls can be devirtualized now. Does that make a difference?
Which one?
You can. I know the jitter will sometimes successfully devirtualize. Will that make it faster than the delegate?
So delegate would be slower than the virtual. In some cases.
In some cases.
If you could devirtualize the call, yeah.
If you didn't override it, then it'd be really fast.
Yeah.
Well, I don't really want to seal the class either because
the only thing you can do right now is add state. You cannot actually control any policy because you don't have any virtuals on that time.
No.
But honestly, I can see how allocations for APIs like this have very large impact on performance.
Oh yeah.
Still, this thing is doing I/O, like virtual call. It's not.
Yeah, they're not that big of a deal. But I still at least wanted to not knee jerk and create a whole gazillion of them. The real scenario, I think I brought it up in the beginning, but again, is not. It's the metric is, moderate to huge data sets, right? So and recursive and hot I/O, right?
Yeah, honestly,
because that's where we really that's where the noise really starts to come out, and you start to see the real weight of the .NET being added on top, or Win32, which is another problem that I'm getting around part of that. But it's the string allocations in particular are what just absolutely kills. And I made a real trivial change to 4.7 whatever our next one is that's coming out.
Yep.
But I took the existing one in desktop and just removed all the places where we were allocating an object on the heap unnecessarily and made the struct blittable, and it cut evaluation time for some of the projects that you guys are measuring to 17%. Just phenomenal jump in for doing something relatively trivial. And that's not even getting rid of the strings.
But we've been telling people that allocations are just
free.
Pointer bump.
Yeah. But
they are.
Allocate memory.
But it's phenomenal how much. But the vast majority of what they were seeing with perf, they were doing things redundantly, but it was all around the string allocations. That's what's killing you guys. And it's those little pointer bumps are just enumerating the examples that I had, right? It would cut on my dev box, which is relatively well powered, but it cut garbage collections by to an eighth of what they used to be, and performance is over double for these, right? When you're
I think if you talk about performance
and building the final strings, which is that's still kind of a crazy scenario to build full pass off of everything. Normally, if you're going to be going through something that huge, you're looking for some subset of data.
And image doesn't even create full paths; it just creates the path from the original directory down to the file, right? So
so the size of the strings or whatever else, but you could keep those things separate as well, the directory portion and the file thing, and never put them together unless you really, really have to. There's lots of opportunities, but there's just the sheer number of strings. What did I think it was? So David Keane was doing the examinations on his he was looking at the one project when he started. It was multiple terabytes worth of allocations on startup.
But you need this.
Yeah.
So
they have a very deep folder.
Way to know when.
Yeah. So what was I think it was to the tune of 4 terabytes or something like that on startup of allocating strings.
Startup of what? VS.
Yeah.
So is that basically the whole API? Is this enumerable and bunch of
and a few well they're the only two ones that we would probably want to look at is I have two filters already, and that's the DOS transform or whatever I call it.
Yeah, these two.
No,
Oh, the transfer.
the DOS matcher and simple matcher. So DOS matcher is at the beginning.
Oh.
Should it be wildcard matcher rather than simple matcher?
Whatever we want to call it. That's why I want to talk about some. Look at the other one, DOS one. Beginning.
All right.
Should be. It's directory, so after directory.
Control it.
There we go.
There you go.
That's matcher.
So this one is the Windows heuristic, right? So it does exactly what Windows does when you pass stuff on the command line. So star dot has a very specific behavior, which is not like representable in Unix or foo dot.
Existing get files and get directories implementations go through this then, presumably.
Correct. But right now we tried to replicate some of the behavior on the Unix side. So like you have these, like when you have like trailing periods and things like that where stuff gets kind of wonky, like the behavior is not going to be consistent, right? So, but that's what we do. So I'm providing that. If you really want to do that on Unix now, you can do that, right? But I'm also want to provide these things like you eventually a little bit more upstream.
How is this type used?
It's used to do the filtering, right?
So why is it this static class with two methods as opposed to the delegates that I can just pass in?
Because
right?
What?
It's probably used in your implementation at some point.
yeah, you use it in your implementation.
Like similar to this, right? If you look at the sample code that was in here, right? You would do a combination of this. You would say, well, is it this one? And is the extension one of those? Does it match this particular wildcard?
So it can be combined, you're saying, with
which seems easier to call a method
than delegates.
And the rules are super complicated. So there's another API on there as well. And I mean, I have the comments in the source code, but like there's actually more wildcards than star and question mark. You know, there's quote and
so
less than and greater than. But like so the translate is for that, right?
So I understand. So why is it not, like why do you have DOS matcher and some other matcher and you know in the future maybe we will add more?
Regex.
Why not just one static class with basically helpers for common things that people would do with you know directory when they enumerate the directory?
That's reasonable.
What does translate expression do here on DOS matcher?
That converts the stars and the question marks to the actual so like star dot is actually like quote, I think, but like I forget which one matches up to which, but like
wouldn't match pattern do that? Like I just pass in what I know and that greater than, less than is an implementation detail.
I could like provide, that's another option, I could make that the default is that it automatically translates it, but from a performance standpoint, you want to do the translate once. If I translate every time it comes in,
you could cache it, right? Yeah, just identity equals the thing I last translated, then it is the result.
I'd have to build a dictionary of stuff, and like, I think that's a little bit much. That's why I have it as two separate methods. Because as you're going through the matching, right, you do the translation to begin with. Because there's a cost to that, because it changes the string.
So I missed that. Translate expression does what? Like some normalization of the.
So the real set of things for the thing is star, question mark, quote, less than and greater than.
Right.
And depending on where periods fall, you end up getting some combination of these for the actual algorithm.
These are things users almost never see.
Like it's all hidden.
One guy in Windows ever sees greater than, less than.
Yeah. So you can pass them in right now. You can pass quote and less than even at the DOS level, and you'll get a different set of matching behaviors. So we have to handle them, right? But I mean, most people just don't know that, right? But like we have to handle it so it matches the other behavior. But most people don't expect it to not be translated. So star is actually treated like star, and question mark is treated like question mark. It's just there's an intermediate step in the Win32 layer where it takes some of the stars and some of the question marks and converts them into these things to give you that weird DOS behavior. So that's what that does. I mean,
that's translate expression.
Yeah.
And is it does the transformation resize?
Yes.
Oh, it can resize. So another thing that like would be interesting because
it's taking
like, if you
star
could-
dot and question dot and turning it into
if you could do it in place in a buffer, basically.
Not really.
Because now you basically created an API to the string allocation. You created an API for
the translate one allocates a string, but you do it
once per what? Per call?
No, once for the entire enumeration. This is the you're translating the filter, so star dot foo is actually like less than foo.
So this is not an API that you would use inside the method, but the lambda body that you was talking about, or you were showing us something.
No, the other.
I would expect to do
the filter
somewhere between these two lines.
Yeah,
you just translate your pattern.
You'll see the other one. There's actually the filters have a wrapper around it.
Okay. So the trans.
So I could call it batch helpers or something like that.
In general, if you combine, if you combine the helpers into a single type, I think you will have to call them, like you will have to work on the names of the methods and parameters. Because they will become, like right now the type name is called DOS matcher, so you can kind of think what the methods are for and what the parameters are for. But
the other one you'd have to hunt it down. What does translate mean?
Helpers.
What does translate mean for
and
that?
And then, you just cannot have a method called translate.
No, it would have to be translate DOS expression.
Or DOS pattern and translate to DOS pattern.
Same with like expression and
I mean, it
name,
wouldn't
like,
be called
what is the
expression.
Name of what?
What?
The name. What is the name of?
That's the passback name. That's what you're trying to match against.
So
I'm using the terminology that they use, but like the expression is the match expression. So start up, foo. The name is what you're trying to see if it matches the expression. So name is what we got back. That's why it's a read-only span car. So that's the data that came back.
It's called file name, right?
It's called name because
in your file data of t info.
We could call it file name. I mean, you can actually use this to match other things. There's no reason why you couldn't.
Could call it text for all intents and purposes, right? Like because you don't care.
No, not really. Because it kind of has to be in the format of the expression.
No, it could be any string. This is the actual result, like foo.text.
So this is, let's say, the translated version of dot star, which I think is like less than something, and then this is like whatever the file name ends up being from Windows or whatever text you want to match.
Yeah.
So like, so it could be any.
It could be arbitrary. It didn't have to come from there. You could get it out of a list and say like, all right, there are these things going to match. What I want to do is I'm going to eventually shove people's face in this, right? I mean, this is starting to get to that point. No, seriously, because it's a problem right now. It's like you will find breaks because you try to put your stuff on core, and like matching does not work exactly the same between the two. So I don't really think people will use this or want to use it.
It will work the same. It's just it won't work the same in Unix. Is that
that's the problem. I'm saying like it's not cross-platform. We don't have a cross-platform way to describe this. One, because the algorithm wasn't available and it's horribly convoluted. Fortunately, we had already exposed it in FileWatcher. I'm just kind of rolling it upstream a little bit and publicizing it. But like by doing this, I want to eventually get to the point where, like, as part of the options and things that we have, as we go down and provide more easy wrappers, we go down to the simple matcher, which is just like it's star and question mark period. And
so name can be named as pattern, right?
It wouldn't be the pattern.
Pattern is the expression, I think.
Yeah, the candidate.
Could be called input, like that's what we do in regex, right? Call it pattern and input.
I don't mind. I would like to match whatever regex does. I mean, I started with what the actual, it's RTL is name and expression is what it's called. That's the actual Windows API. It's public, but that's what that thing provides. It provides a cross-platform version of that.
And the parameter in our case, is that the only thing that we need? Because will people want any culture information here?
What do you mean?
I assume this is ordinal in our case?
It's ordinal.
It should be invariant.
You see?
Well, it should be invariant, not ordinal.
Why?
Because the file system by itself, it grab like the data of the kissing table from the invariants in general, and and store it in the file system itself.
Did I?
To do the casing. So
I can't remember
I
what I did.
can
I tried to. I want to match whatever the file system does. I think I did. Sorry, it's been like I took a.
The problem is you will never match the file system because, as I mentioned, the file system snaps the casing table inside the file system itself. So you cannot access this. But
so how does that work? If I change locales, the file system updates its table?
No, they grab the data for the match.
This is why they are using invariant.
I see.
So yeah, I mean, like the guidelines for the comparing for the file system, we always tell people use invariant.
But I think if he specifies ignore case false, it's just an ordinal comparison, right?
I don't remember. I have to look at the code. It's I have a branch with this up in it. Like it's actually in there right now.
No, you can have invariant in ignore case.
Yeah.
Right.
But
Oh yeah, you can.
I'm
in this case, I would be surprised if they did anything but ordinal.
I'm pretty sure they're using ordinal, but I need to go back and look. But like looking at the Windows code, they're just the table that they're loading, that they're using is the one that comes as part of NT startup. I'm pretty sure that's ordinal, right? Or is that invariant? Sorry, I'd have to go.
File system.
I'll talk.
There is a classical.
You didn't implement none of these routines, these match routines. You implemented in C# or did you?
Yeah, they're C#.
You implemented them?
I have to because I can't we have to do it in Unix.
You can call the Windows API through Unix, right? That would not work very well.
So I'm using our 2-upper. I'm actually calling on the Windows side. I'm actually calling the same API we call inside. I'll get offline with you and look at that.
So
but
these are also allocating, right?
What?
They are allocating, or you do it char by char.
I do it char by char.
We need to test all the surrogates.
Yes.
And this is
the file system is actually pretty simple in the way it does its matching. So, but I'll definitely take it offline and we'll look at it. But I was very, very explicit at trying to match the exact same API semantics. It's hard to follow though, so I could have gotten it wrong. Like the way it loads that, I mean, that's really, really early in the startup of MT, and it's really hard to read that.
If we got it wrong though, it wouldn't just be the new APIs that were not quite what you wanted, but get files and everything and now implemented through that, right? So it could be
everything is implemented on this right now.
Too, right?
Like it has been for a few months. Like it's going through this DOS matcher.
Oh, okay.
You haven't lost any data yet?
Oh yeah.
Good. So
I wanted to ask about dot.
I haven't heard about it. It doesn't exist.
Nobody passed an expression with the circuit? Yes.
So you get called back for dot and dot dot. What's the scenario there? Why not just filter them out for me?
So you can tell when we're starting.
Well, that tells. Yeah. Okay.
No. There was some call for that. Like I don't know. Like I could always make that default. That's come up also in the questions. But I've never seen a scenario for it. But presumably, and this just may be everybody keeps passing the buck down the chain. Is there must be a reason why it was provided.
Why do they exist? I mean, I can go cd dot dot and it's a shortcut for going up or change directory dot dot.
I don't know. They're all virtualized. NTFS itself, in the case of NTFS, doesn't there's no actual entry.
Maybe because that exists everywhere on the root.
Does find next file give you dot dot?
Does it give you a dot dot? I haven't thought about that.
Yeah, it could be.
I have to look. That's a good question. I don't think I've ever
That's the only reason I'm just thinking why they would even have it.
It corrupts your file.
It's, implicit. It's there all the time.
That's an interesting question.
Find next file give you dot dot. Huh? Find first, find next. Do they give you?
Oh yeah. We just the existing APIs we filter them out. That's all.
What does Unix do about them?
Yeah.
You give them back as well.
So it's not in the root.
Exactly. So now you basically need to have it because it's not everywhere. What? If it was everywhere, imagine that exists in every single directory on the file system. Then it doesn't make sense to print it because it is there. There's no reason to print it.
It doesn't make sense to print regardless. I've never looked at a printing of dir and said, "Oh, look at these two files over here."
No,
It's amazing that they're listening.
imagine that you're walking directory up. You basically walk all the files, and then you notice that, and you go into that, and you keep doing it. And when you get to the root, there is no that, and your algorithm stops.
You're saying if I have a bug, it prevents you from doing stupid stuff?
No, it prevents you from having recursive algorithms.
It stops being mischievous.
I think so too. I think you're missing.
It's 2 hours of API reviews.
Yeah, exactly.
So the other question that I think we had, I don't know whether we talked about this, but find transforms and find predicates, I think we could probably merge, right?
Yeah.
There's no reason to have like 2 static helpers, right?
What would we call it?
So one suggestion I have is, can we make them extension methods? Now that C# supports ref extension methods?
Or we,
If they provide ref extension methods now?
Yes, they do now. And
Statics?
Okay, why are they extension methods? Why are they not properties on file data?
Because we can have a whole bunch of them.
Because what?
We'll have a whole bunch.
How many?
25.6.
Eventually, right? I mean, people want to write their own too. I mean, they can write their extensions.
Then
But
they can write the extension, but
like we want to be adding others, yes.
How many will we add?
1 dozen, 2 dozen. Over time.
When did we switch from like not adding members that make sense to types and having them as extensions? It doesn't change anything. It just adds additional time. Like it doesn't make any sense.
But you're also building here, right? You're composing. You can't compose if they're sitting on. Well, if they're statics, I guess you could.
Well, there would be instance methods. You just call them, right?
Yeah.
Huh?
You just call them. Like they're regular instance methods. I mean, you have to pass in it find data anyway. Might as well just, instead of saying, as directory find data, you say find data dot as directory, right? Like it's the same number. It doesn't really change anything, right?
Let's not go into the mode of like, we want to have less members, so we're going to just move them to some other type. And now we're going to have the same number of members, but more types.
So I get it. Just like, but like there was, I guess that's fine. Yeah.
The other question I have, like, should they be called to rather than as?
Huh?
Should they be called to rather than as? Because as kind of implies it's cheap, versus, relatively speaking to this feature, that's an expensive method call, right? Because the whole point is that you don't L1 allocate. So I would call them to directory info, to file info, to file system info, to user full path. Because it's basically a conversion, right? You basically do something heavyweight, which you shouldn't do in general, right?
It's fine. I don't care. I mean, like, what's our precedent here? Do we?
And these I kind of can see how they are, extension methods, because they kind of create a dependency between very lightweight new world and.
Well, they're all the same assembly, so I'm not sure that.
They're not in the same assembly.
Yes, they are.
Are you adding them directly to .NET Frame, to like .NET Core and .NET Frame?
This is all file system. System.io file system.
Ubing will be interesting. I don't think anybody asked for that yet.
What?
I said Ubing will be interesting with that design, but I don't think anybody asked for that yet. So let's not go there.
Well, it's file system Ub.
So
It's not. It's
What?
just it's
No, file system. No, file system. System.io. So directory info, file info. Those are all completely in Corefx.
So how are they gonna use it? Like MSB?
Well, that's another question.
Oh wow.
The potential here was to like actually have two there's a number of things that we can do. Like the OOB thing is complicated, but like we could provide we could share the code into a different assembly that allows them to use it until it bubbles its way up to something where they can use it universally.
And there's Spender. Is that? And there's also Spender. Does it have any? I didn't look at how it's implemented. Does it have any?
Span?
Yeah.
So Span is a standalone. That's an OOB one. So you can take a dependency on the system.memory.
Okay.
So it would be system.memory and some other
But before we go there, all I think I would like to say is that if it's OOB, there's no layer rate problem. Because we clearly sit above underscore, we clearly sit above whatever the primitive is. So like these lightweight types cannot be lower than directory info is, because directory info is already involved.
So the tricky
they're not a problem in terms of whether they're instance methods or not.
The tricky thing for this one is that like there are internal optimizations, so your performance is slightly better when I have internal constructors for directory info and file info. So if you were actually creating those, then you would take a performance hit, an allocation hit, if you're like using an out-of-box scenario.
But like they won't be creating those.
I wouldn't assume you guys do, but like that's one of the reasons why like having the whole thing out of box is not a great idea, right? Because it like adds significant allocations. We could add new members, new crazy constructors to public constructors to directory info and file info that allows you to pass in raw data. But
I'm not sure how it would help you though.
It would help me in this case, like if you're running on core, you're fast without having to do
Initializes those old types. You just by writing to internal fields.
No, I'm saying but it doesn't help you on platforms where you're not in box. It only
no, of course that's like, but like until you're in box from somewhere, you if it's in box, you would the places where. In core, since we control everything, I could even do it through reflection or something stupid like that. But like I have the ability to initialize those things more efficiently.
No, I'm saying like if you're in box, it could be an internal constructor because the thing could live in the same assembly with the other types.
Yeah, that's what it is right now.
If you're not in box, like .NET Framework, well, you don't get to add a new constructor to directory info because otherwise you might as well just.
No, that's what so it's extra. Like it would be like, does that exist? Like, I can use it. If it doesn't, I can't. So like, you build the desktop one. The desktop there's a desktop version of this assembly.
I guess what I'm saying is like if this feature goes out of band, the way I expect the feature to be is I would expect that you build twice. Like there's one implementation for core, where you don't have to check whether the constructors exist. You just call them because this is the compilation of the assembly for .NET Core, where you can call the.
Yeah, but like as a rule, we haven't like provided internals visible to, so we'd have to add some ugly. Interfaces to, ugly constructors.
Well, you could even make them public. All I'm saying is that from a Ubing standpoint.
Sure, yeah, I get it. It's like those constructors were ugly. That's like.
But going back to the customers, so basically we are adding this API, but customers cannot use it, so they're gonna take a copy of sources and use it. Is that the plan?
That may not be terrible
for some things already. Like ideally we'd be able to move desktop faster, they'd be able to consume it faster, but like, there's multiple things that keep that slowed down for you guys.
Visual Studio will take a long time.
Yeah. Even if we move desktop fast, the Visual Studio takes a long time to take a new one. So I want to come up with a solution where we can continue to. One of the fundamental design things I'm trying to get at it with all this stuff is I want to stop like rewriting the same low-level code all over the place. I want us all to be sharing logic because it's easy to get this stuff wrong, right? And subtly different between implementations because it's just so many subtleties. We just talked about a few of them with the wildcard crap, right? Like it's better to have one low-level wrapper. Now, if we can oob it. There's tax that comes along with that, right? Adding a whole other assembly that we then depend on. Because, like, I'm built on this as well, right? But if we decide that that's the way we want to go for this one, I'm okay with that.
We don't have a magic solution.
No, let me put it this way. I don't care which way we go, whether it's building another, like assembly, like a whatever we want to call them, prototype or like advanced or something like that like gives some people an out-of-box solution for the exact same code that's in. We just include the code in both places. It allows you to just take the dependency on that assembly.
And as long as it's a different namespace, there's no problems whatsoever.
No, and this is sort of orthogonal because like they don't really need the creating the directory info. That's the only tieback, right? Directory and file info stuff to the rest of the system. And they can write, we can write little wrappers in there even that like give you the same helpers to get the same old behavior if you want it or whatever. But like,
and then it's span. You have to redistribute what was it? System memory.
System memory is what span is.
A question about matching, like the expression. How large is usually the expression?
Huh?
How large is the expression when you're doing the matching?
The expression, well, it's for file name, right? So, file names never get beyond 255 characters.
Okay. So in that case, that could be a stack as a char array.
It is. it's significant stack allocating.
So can we use that as a real span of char instead of string?
Which?
Match pattern and DOS match pattern.
Oh, that part? You could.
There's only one though, right? So it's not like there's one.
Yeah, I didn't try really hard at the one cases. I mean, internally, I thought that's what you were talking about. Like internally, when I'm doing the work, because it's a small set of stuff that I'm like matches and things, I stack allocate the stuff that's.
I don't know whether
there's a couple of
you guys wrote down guidelines for when to use span in APIs instead of string, but I mean, I think there's a sophistication bar and there's also a like frequency bar. You know.
I don't know if I ever.
And the other thing is,
I don't think I do string.
should the defaults like bools be default to false, like as the default values? I think that's something you mentioned.
Well, that's our guideline that says when you default a parameter, you default it to the default of the type.
We've done ignore case in other places, and it's always to true.
It's probably not default. We just have overloads.
What does it matter?
But I think in this case, basically, it doesn't matter, make sense to make new overloads, and it doesn't make change. So basically, the way to, let's say you wanted the true to be the default. What we would do in the past is to be able for the parameter to be false, you would reverse the wording. So you would call it not ignore case, but rather other case or use case. And then it could default to false. But in this particular case, I don't think it makes sense because ignore case is such a common name that now changing it to
Well, you could call it case sensitive,
which is
a pretty common thing for.
I can turn this to false anyway. It doesn't really matter. It's just
I mean, I would say though,
it's just knee-jerk because of the like Windows and Mac both ignore case and like.
I would say like I don't buy the guidelines if we say overloading can change to, like can default to non-default values, but default arguments can't, because like if you look at the call set, it's the exact same thing. You just have fewer arguments.
Yeah, and that's why I said we have this guidance, but I'm not sure whether it's valuable.
Okay, we've gone quarter of an hour over. Should we call it a day? I think Jeremy's got some tweaks and open issues to address, and then I imagine that we'll want to look at this again, but for less time.
Well, yeah, I think. Well, there's some things that are very easy to address based on the feedback that I don't think are contentious.
The biggest one was whether to use an abstract class or not. And I'm not sure there was really a consensus on that.
I don't think. I think the consensus I'm seeing right now is like for at least the next iteration is to move reduce the size of the constructor.
Right.
That was a pretty clear one, and I can do that through a combination of those things. And I think I want to explore addressing scenarios. I'll come back with a definition that looks that way, right? That has a couple other virtuals on it, and I'll toy around with the non-necessary ones. So the two that you absolutely have to have are some. Well, actually, I guess filter doesn't have to be there either. So I'll look at it. But the transform is an absolute must. So
the other thing we should close on is like, what's the namespace?
Unless you return default.
Should we put it in a nested namespace like IO enumeration or something? Or do we want to keep it in the root?
It depends how many types there are.
I know. I think honestly though, like the number of types, like we have definitely find data, we have definitely find numeral, right? So we have two types.
And then no.
Well, find options, we said we were wanting to move it to a struct.
So find options will either be struct or enum, but it will be a separate type most likely, right? Unless we can merge it with find numeral if we make it an abstract type. Then we already said the predicates will either be. Yeah, I don't know about the predicates. The predicates you have to have, I think, unless you move away from.
How many types are in regular expressions? There's only like 6 or something, right?
But regular expressions is in own assembly.
So
not mixed with APIs that are like so commonly used. Like this is a namespace that contains files that read all.
Right. That's why I'm saying there's precedent for having a namespace with relatively few types in if it's really quite coherent.
Oh, okay. You're saying to move it up, yeah.
I honestly think, like, to me, the bar is mostly like, do we expect these APIs to be used by many people? And the answer is no. Then I think it's okay to say.
Well, if we have it in a lower namespace too, like we put it in the OOB assembly, then
you could do that.
Directory, right?
Well, namespace in
You had it right
API
there
kind
as the
of
second
independent.
entry.
Yeah, was it? Oh yeah. Here.
Well,
But
it makes it's an easy.
This is more.
But I think that
It's easy to call. It's easy to name that thing, right?
But I think that this API will not be used by a lot of people.
Right.
I think you have like helpers in directory that help new helpers
Yes.
Yeah.
that will solve majority of the problem. They will solve the problem of this API failing when it cannot access an item. And the problem for the average developer is solved. Now we have a second problem, which is performance, which is not for the average developer. And then they can access a new namespace.
Yeah, I honestly think that we will probably add more stuff to that namespace eventually. Like as you said, you want to expose some more Unixy stuff. And I'm honestly fine with saying, even things you consider platform agnostic, like DOS matcher, to me is something that I would put in the namespace because there's 5 people in the world that want to call this. And even if we have OS-specific APIs that literally blow up on Windows, I'm also fine with putting them there because this is a low-level building block namespace at that point. It's
I'm fine with putting it in a subnamespace.
So
That's another interesting question for you though. Is changing this from an enum to a struct. How, for the find options, right? How difficult is the cognitive load there for users on the existing things? Flag. Have we done that much in other places? Because flags has been the standard that we've done to this
So
point.
honestly, one thing we could consider in the APIs on directory, instead of passing find options, why don't you just have a boolean and say ignore inaccessible?
Because all those things are useful.
Well, they are useful, but maybe then you just have to use this other namespace, and you just use no more.
I'm fine with them adding you can have stuff from that other namespace and use the method, right?
You could say, but you ask about hey, it's a bit more.
But constructing it, right?
It's a bit more tricky to use a struct that is mutable, has properties that are weird.
I have to create it as opposed to.
So if we use this
or a bunch of
struct,
things.
in those mainline scenario APIs for the millions of developers, then you have a point. I mean, we just made a bit more complicated API, whereas the only thing that they want to do is ignore errors.
Exactly.
Not all of them.
The thing is that those values belong to different domains. There's accessibility, something with buffers, recursion. There will be traversal options. They have different meanings. So if they have different meanings, maybe they shouldn't be in an enum. A struct with more enums. An enum about what to do with accessible files or network files or another enum on what.
So there might be a tri-state for some of the other part of it, and some option.
I mean, it depends on your model. I mean, if this thing is a struct, you can do whatever you want, right? I would almost say if it's a struct, make them all booleans because if you're concerned about size of the struct, well, it's your struct. So in your implementation, you can have a 32-bit packed enum with 30 flags if you wanted to. So you can all them, in one giant field if you want to.
Size of the struct.
In that sense, but really the only concern is, non-flag style, values like the buffer sizes themselves, which you can represent.
Well, there that and what he was saying is we may get to other things that may have a tri-state.
True, but that to me is I don't care because I would say flags can have mutually exclusive things in the same, as long as the ranges are non-overlapping, it's all fine. The biggest problem is usability at some point. If you look at binding flags, there's so many things you have to set to get any results back that it's usually hard to get it right the first time. But if you make it a struct and you just have 12 properties that are all of type bool and you can all set them independently, well, who cares? at that point, I don't think we need a different type for recurse and then a different type for accessibility. You just say
that I agree. But they may not all be bools, is what I was saying.
Well, then you make it nullable.
Yeah, which is fine.
Or I'm just an enum, correct?
Yeah, that's what I'm saying. I'm saying that goes to his argument, as to why you would do it.
So maybe the thing I was saying is the mainline scenario APIs on directory type.
Yeah.
I would not even use this struct.
I want to have something there that is extensible going forward because there's more than just ignoring accessible.
Like what else?
Track recursion and things like that. These are the things that people are falling over and skipping using stuff altogether.
Then you use
No, what he's saying is different, right? He's saying we have these APIs here, which are used by a lot of people. Not this one here, but these guys here, right? They're used by a lot of people. The problem is that like this API here, this one here, that basically allows you to recurse today, doesn't work in a lot of cases. And in order for you to use something else, you have to rewrite that, basically recurse yourself and catch exceptions, for example. Super annoying, right? So the value would be that we give you.
Doesn't it work?
So, for example, let's say you enumerate the seed route.
Yes.
Unless you're an admin, the thing immediately
That's the ignorer.
No, the other one
That's
is
the ignore errors.
So that's the errors, one which we don't have today, right?
So I was said instead of that's what I was saying. Instead of adding this find options here,
right?
Just add boolean ignore errors.
because there's more.
Okay,
right?
but what's for the next boolean? Like, for example, the
so
thing
then,
that.
then I ask, what is the next boolean that we
So
are
it's
thinking about adding?
It's the track cycles, because like this is like by default, right? Like I said, Java will track the cycles if you do recursive, right? We don't. So like cycles is a problem. This is one of the main reasons why Windows didn't have the write on by default, is because cycles get introduced into the file system and most programs fall over. Right? Why? Well, now because most programs are written on .NET. But you know,
So I think the problem is that we want people, like the people that don't care, we want them to be successful. Today there's two things that if they have to rework it themselves, like we lose them basically in the process. They're not going to rewrite the whole thing with the new find data thing, right? They can barely do it in this.
Okay. So what about we had two boolean parameters, ignore errors and ignore cycles?
I don't expect it to stop at 2. I expect there's more. Like the other one is important too. People have been asking for that because they're like, my SMB performance sucks. Why don't you have the ability, like, so when you're going to a network share, enumerating files is horrible because we have a 4K buffer instead of a 16K buffer.
I'm saying, why is it not reasonable to tell people import the other namespace, create a numerator, and set the option?
Well, we could, but like, I mean, these things you keep going down the road. I mean, some of them are more esoteric than others, and that one starts getting a little bit more subtle.
This is a good example of something where, ignoring full framework for a second, I don't know what we would do there, but on core, I would feel somewhat more comfortable saying, we change our implementation to not fall over when you get an access denied, and like we change our implementation to not fall over when we hit a cycle and not run out of memory, because basically we just make things that would fail spectacularly fail less. That seems generally like a safe thing to do.
Yeah, and like. Yeah, and I would want to do that outside of the fact that that's so fundamentally like breaking from like how do you like.
I think for cycles,
I
think for cycles we should probably. I mean, unless you allocate now a shit ton of memory in order to
track
the cycle,
it has significant performance implications.
Because you have to
tracking. That's awful. It's hard.
It would be horribly not performant, correct?
Yeah, it's really really bad for performance.
Like meaning you have to basically record every single place that you visit.
Yeah, well, you can't get rid of the directories that you've tracked. You have to keep the handles open and see if you get the handle again.
Yeah.
See, I mean, right now, I have to open all the handles anyway, and I keep a bunch of them open depending on how you're hitting. Right, the way the implementation is right now, like as I hit the directories, I open the handle on them and I hold that handle until I'm done with that directory. Right.
You could probably start
but
tracking cycles once the path gets really nested. Right, you just track the nesting. And you suspect,
Well, you can hit it even too. So like it ends up.
I'm hitting the cycle, then you start tracking cycles and say like if something.
Like Windows got rid of it, I believe, because there's I don't know if you can still get into it eternally because there's they put a hard limit on the number of reparse points you can have in a path. But I'm not sure, like with our logic of walking down it, right, whether you can. So if I go and open up another directory, I'm giving it a full path, right? Right. But they would prevent you from actually navigating to that point because once you hit 10 reparse points, they blow up. Now that said, there's another optimization that I'm intending to do that I haven't done yet, at least in the actual public code, is that I don't want to give it the full path anymore because there's another like 3 to 5% of performance gain to be gotten there, at least to use the NT create file where I can pass it the base handle and then pass it a relative one. But there I would never know, right, in theory.
Why don't you just, I'm sorry I missed this, why didn't you just crop it off when the path gets to like 5,000 characters? Was some max path at 32K?
Yeah.
You can't cut it off there, by then it's too late.
Well, that's a huge hit, right?
But this is just for the rare catastrophic case.
It happens apparently more often than not. well, I mean, we had to rewrite it. I don't know if you guys have your own.
Right. Can you send me the file? Okay, just not send me not by email because Outlook is
blend when I did it.
Just upload it somewhere.
Actually had to deal with stuff.
So
But the way we dealt with it, we just ignored the reparse points.